feasibility condition, we know that we know two terminologies, which is what is feasible distance and advertised distance and so forth. And also I've shown that topology, and where even you can see the working of the TIJP using the Cisco packet tracer, right? Okay, so the next we have to discuss inter-autonomous system routing protocol. So uh, which is widely used, and it is the only protocol we have. And the complete internet is running on that protocol, which is BGP. Okay. So as I said, the BGP couldn't do that in the Cisco packet tracer. We could do that, but only in only some experiments we can do it. But if you see that in extension of this BGP, so where you cannot do that over this simulator. So for that we have to use another one, which is GNS3, and I'll just give you that demonstration how to use that GNS3 protocol using the Okay. Am I audible?
Yes, sir.
My screen is visible, Karthik?
Yes, sir.
Okay. So today we'll look at so what is DHCP, and how you can verify that the same DHCP process using Cisco Packet Tracer. Okay. Along with that, we would also look at NAT. So what is NAT, and the implementation of NAT using the Cisco Packet Tracer. So along with that, we'll just look at what is VPN, different types of VPNs, and implementation of a VPN on the Cisco Packet Tracer. Okay, so we used to do point-to-point, or what we call GRE protocol, generic routing encryption protocol, and another one is DMVPN, and also we will look at IPsec implementation in Cisco Packet Tracer. Okay, and this is the one of the most type of implement real time we would be using it, right? The VPN. So one of the type we will connect a point to point over a internet type of WAN connection. So we will look at all these things. Probably I will just look at whether I could be able to cover the whole things. How much it is possible, I'll complete it today. The rest will be completed in the next class. Okay. So first we'll move into the very one is DHCP. Okay. So DHCP stands for, can anyone tell what is DHCP?
DHCP, sir.
Hmm.
Dynamic Host Configuration Protocol.
Dynamic host configuration protocol. Okay. So the name itself tells dynamic host. Host ಅಂತಂದ್ರೆ you can say it's a device, a computer. Configuration. Dynamic means something automatic. Host configuration protocol. So what we are configuring here, by assigning some IP address, default gateway, and gateway, what is the gateway address, and the DNS address, something like that. By assigning this information, or we are configuring with this information to the host dynamically. Okay, so this couldn't be uh, done by a network administrator. So earlier manually means it has to be done by network administrator, but this service also we automated and we made that to call it as DHCP. Okay, we just say that device should be automatically get configured when it is connected to a network. So you also do the same thing, right? In our college, when it comes in and if you turn on that Wi-Fi, so everything is ready, you can start using that internet by authenticating. That is we made it. Okay, so when you logged in Wi-Fi, it will ask username and password. So So if you remove that username and password, you will straight away can go and use the internet. It's something authentication. We have to authenticate whether the users or students are belong to SJC or not. Otherwise, everyone will come and use it our service like internet, right? So we just made that to authenticate. Okay, and means you would be not knowing how this will be configured. What is the communication which between exchange between your device and the router or DHCP server to get assigned with this IP address. Okay, so you can see in this. Am I audible?
Yes, sir.
Okay.
Yes, sir.
Too much of noise, sir.
Okay. Just a second. Now it's audible.
Too low, sir, volume. It was better before.
Now?
Yes, sir, can hear, sir.
Okay. So here what we are doing, I think you can see here a simple network. I have 3 routers and 3 networks, and this server is going to be a DHCP server. Okay. Even you can configure a router acts as a DHCP server. If you configure that on router, it simply create an overhead because the router is mainly used for forwarding a packet. That's it. Even you can add that functionality to it, but that simply create an overhead. Okay, that may get delayed with some other type of process what we have. The primary function of this router, because it has to do the both the things. It has to allocate the information, the IP address, and also it has to do the forwarding job, right? So what we were doing here, so instead of assigning creating that on one router, on a router, we would just having a separate server which we called as NDHCP server. Okay, but we were knowing so something called broadcast domain, right? So how many broadcast domains were there here? Okay, the number of broadcast domain in router is equals to the number of port, right? So how many number of ports are there is equal to that many number of broadcast domain. I think you remember that basics of this broadcast domain and what is this, what is called collision domain, right? So once we know that, like once if you enable this, okay, I'll just go here and I'll just configure, and if I click on DHCP, so I'll just check that in simulation mode. Okay, I'll do it here. I'll do the same thing if I connect. Okay, if I click on this DHCP, it create an DHCP packet. Okay, you can see here on right hand side, and it creates a DHCP packet. See, DHCP packet server, and it's use default address 0.0.0, and UDP port number is 6. Source port number is some random number 68, and the destination port is 67. That is for DHCP. And source IP is 0, and the destination IP is broadcast address. Okay, it is limited broadcast address. I think you just remember limited something, directed broadcast address, limited broadcast address, and this is address we call it as limited broadcast address 255.255.255, and this is the source MAC address, and this is your MAC broadcast address because we do the broadcast. Okay, once if you click and forward, Okay, that will come to switch and it comes to know the broadcast message, the destination address, MAC address is broadcast. So it simply forwarded that to everyone. Okay, and even see it simply forwarded and it doesn't know. And one more thing, I have to turn on this device. Okay, this interfaces. Okay, what I will do, I will assign an IP address to it because if you are not logically turn on this interface, the broadcast message will not send on this link. Okay, that is why I'm doing it now. So I'll click on this F0/1 and I'll assign the gateway address. Okay, 192.168.1.0 and subnet mark is default. Sorry, 192.168.1.0 and subnet, sorry, dot one and subnet mask is this and I logically enable. And another interface I used to assign that IP address which is 10.0.0.1 and go with the default gateway address. Sorry, go with default subnet mask. And similarly, I will do it here also. Okay, I'll do it here also, which is 0/1. I give it this 10.0.0.2 default gateway, then I'll turn on. And for this Ethernet, I use the default 168.3.1. Zero. I assign with 11.2 this network. Okay, so I used here 192.0 network, 3.0 network, 1.0 network, here 10 dot network, 11 dot network. Okay, I do the same thing which I did in last time. Okay, I'll just click on here and I'll go to IP configuration and I'll just click on DHCP. Okay, and if I open this, the same thing which we understood last time. Okay, so broadcast address and it's use a broadcast MAC address also. So as it's forwarded to the switch and it comes to know it has to be forwarded in the LAN. So that would send on across that will be sent on each port on the switch and that would also receive that router. Okay, but on router, okay, so it will not forward it to the next stop because basically the default behavior of this router, we know that it doesn't forward that packets to the outside or means on to the next address. That is what we know that, right? So broadcast, the default behavior in the network or router, it doesn't broadcast any of the packet to the whatever the broadcast packet it comes, it doesn't forward to the next stop, means another interface. So, but if you look at here, to get this PC to get assigned with the DSCP, this packet has to be sent to here, right? Because this knows which pool and which address I have to assign to this PC. But here itself the packet is not moving it, right? Okay. So what we should do it? So in order to do this, so we have something called relay agent, DHCP relay agent. So by using one simple command, we can able to get assigned with the IP address for each of the PC. Okay. So in order to doing that before, just understand how if I configure a DHCP over here, or if I configure here within this network, I would able to do it. I means this PC would get an assigned with IP address because the DHCP server and the clients which get wants to IP address, it all belongs in the same network. Okay, so I'll just enable it. I'll click on this DHCP server and I'll go to this DHCP services and I'll just name the type of services. Okay, I'll just create some pool name which is called LAN1. Okay, LAN1, and I used to use the default gateway as 3.1. Okay, 192.168.3.1, and I'll assign the DNS server IP is 8.8 and 192.168.3.4 is the starting address. Address and I can limit them to some number. Like if I say 30, it could only assign 30 IP addresses, and this will be optional. Just click add. Okay, and similarly, you are doing adding one more IP, which is to be LAN 2. Let's say that to like 2.31. Here this two add and LAN 3 is to one and same thing. And I'll assign two. If I open this, you could see three pools were there: LAN 1, LAN 2, LAN 3. I'll just name here also. I just call this as LAN 1, where I have my DHCP server, and this I would call it as LAN 2, and LAN 2, and this I would call it as LAN 3. And you should visualize this complete is your complete network, JC network, and where this should be one department, this should be another department, but have only one centralized DHCP server. Okay, and what I did, I didn't anything, right? I just created a pool with a default gateway and a name, and what is the range of address I should allocate, what is the maximum user I should allocate, and I just enable this service. Okay, and I will close it. Okay, if I click on here, whether I could enable, if I click on this DSCP, whether I could get the IP address or not? Can anyone tell? If I click DHCP here, whether I would able to get an IP address, whatever which is to be assigned to this client from the DHCP or not? Yes or no? ಬರುತ್ತಾ ಬರೋದನ್ರಪ್ಪ?
Good, sir.
Okay, so you can check that in simulation mode itself. If I go to simulation mode and if I click on this DHCP, you just look at it here. It's created DHCP packet, and if you open this packet, you will see more information, server, everything. I think you just recall what we discussed this DHCP DORA process in our precision class, right? Okay, and I will close this and I just do capture and forward. Once it's come, it simply broadcast it, and here it is denying, and here also it is denying, right? But it's not getting the IP address. So I'll just come back and I'll just check in real time whether this could be able to get a. It's failed to get an IP address. Can anyone tell what is the reason?
The service is too much.
Huh? Can anyone tell what is the reason I'm not able to get an IP address? But I should get that, right? It should get an IP address and that should be assigned over here. Okay. ಅದೇ ನಾವು ಪೇ ಮಾಡಿದ್ವಲ್ಲ ಅದೇ ಅದೇ 830 ಪೇ ಮಾಡಿದ್ವಲ್ಲ ಬಿಲ್ಲಿಂಗ್ ಅದು ಮಾಡಿದ್ದೀವಿ ಅದು ಮಾಡಿದ್ದೀವಿ. ಅಲ್ಲ ಏನು ಮಾಡ್ತಾರೆ see here I created three pools. One is LAN 1, 2, 3 on this router. Okay, and I just try to fetch the data from the DHCP. I could do it, right? Once I do, once I click on this uh, now DHCP, I would be able to get the IP address. Okay, and similarly, once I did that on this router, if I click on here, but I fail to get the IP address because we know that if this broadcast, it will broadcast to everyone and here also, but this will not forward it to here. Okay, the same thing. If I broadcast here from this LAN, I would fail to get the IP address from the DHCP server. Okay, where it's failed in API IPA is been used means a default IP address which is assigned failed to assign with the DHCP server. Okay, with this 169, it will start from 169 address. Okay, so what I will do, so I'll just configure on this network. Just I will enable this routing protocol RIP as a default. Okay, just router RIP and this and network and just enabling this RIP every router. This was the initial setup which is made by routers. Okay, sorry, administrator. Okay, so whenever any device is connected to a wired network or wireless, something that would request it to DHCP server, and DHCP will send back the IP address and all necessary information to them. But here I said once you connect it to a LAN, wireless LAN itself, it have its own network, LAN network, and it will broadcast it there. But there, if it is DHCP is not present, then it will not allocate any of the IP address to you. So to do that, we will depending on something called relay agent. Okay, we configure a relay agent on every router towards forwarding any of the DHCP requests to the proper DHCP server. Okay, so for that we must ensure it. So whatever we have done, sorry, I think I made mistake over here. What is that? Just I have done. Oh, nothing I have addressed. Sorry. See that's why I'm not getting here. I'm not assigned any of the IP address to this. And you can see if I do this, it get assigned. Okay. I'll remove everything which I did here. Okay. DHCP pool and everything what I did. Just remove it here. And I'll just write this command. I'll show you. I removed that one. Okay. I have to give this case is a case sensitive. You have to properly give the name of the pool. Figure pin 3 2 1 2 right. Okay, probably it would remove those configuration which I did. Okay, so if I do the simulation, I think and do the same thing which I did last time. I'll go back and I'll create the DHCP, capture it forward, send on both sides. Okay, and again ICMP, and it will send back to this. Okay, it's assigned successfully. Okay, but here I couldn't do that. Okay, I just if I click on DHCP, so I'm not able to get the valid IP address which I need from this range of network. For that, what we do, we use something called relay agent. Okay. Okay. So I'll just create a relay agent. So on every router which is not having this DHCP server. Okay, I'll just click on here on this router, and where I have to configure this relay agent on the interface where it's facing towards your LAN. Okay, this is the interface. Okay, so just say f0/1 and the one command which is called yeah, DHCP IP helper address. Okay, and here I just give the IP address of the DHCP server. Configure this. So whatever you broadcasted to the DHCP request, that will be sent to a proper destination and you'll get back the reply. Okay, so only one command. And the same thing I must do on here also, because this is the interface, it will receive the DHCP broadcast, right? So there, if it knows where it should send, so then we should have the DHCP helper command for in this interface itself. If you configure here, it doesn't work. You have to configure the interface where it receives the DHCP broadcast, and it will comes to know on this broadcast there is a helper address where this DHCP broadcast is sent to a DHCP destination. Okay, and for that I have to get into that interface, and I'll just call that as IP helper address to the destination address, which is 3.1, 3.2 is the IP address of the DHCP. Good. That's it. Close it. Now, if I check the same thing on simulation node, click on DHCP, it's already assigned, right? DHCP, capture and forward, broadcasted, and the broadcasted would also received here. And you can see there that would be sent over here. And we know that through RIP, the packet from here, it knows how to send to an 3.2, right? And send to here switch, and it will send to the server, and you can see here 1.1 is the this default gateway, and it will know the destination address is this, and it is requesting for an IP address. Okay, and if you see the next thing, it's an ICMP packet. It's an ICMP packet 1.5 is offering an IP address which is 1.5. Next, it's request an RIP. It send an RIP request, and now it sends another ICMP. So keep on doing. I think somewhere it will DHCP again to start, right? Okay. If I check now here, I think this would get. I think still the DORA process is not completed. So keep on forwarding, capture and forwarding. I think somewhere it will get assigned with the IP address, right? Because and all these things which you are doing it in between, except this DHCP, is actually the default something automatic process which is happened in the network, STP, DTP, all these things. So that's why I would also getting that. Okay, so I think I would able to get even if you are not in the same broadcast domain, which is in where the DHCP is in the broadcast domain. Okay, you can also check the same thing over here also. You can see you would able to get the IP address. Okay. Okay. The same thing you can check here also. Okay. How this is happening? It will send a broadcast message to everyone. Even this packet will receive based on the helper address what I configured. It will send forward that packet to a DHCP server through the dynamic information we already configured, right? It will forward it here. Again, it will send back to the here, and this would know where it's sent to a client and get back. And this DORA process will complete, and it will get successfully assigned with the IP address, subnet mask, and the default gateway and the DNS address. Okay, is it clear? See now that everything is removed. In this file, if you look at whatever I configured as DHCP pool so and so is not there because I just removed it. So everything is now sent by this server. You can think of this server would be kept in my server room. So once the time when you connect it to a network through either LAN or wireless, it send a request to the DHCP server and it will send a response. After that, then it will assign the IP address, subnet mask, and the default gateway. Then you can start using your to the internet. Is it clear?
Yeah.
Okay, this is using relay agent. Relay agent is something I just mentioned here also. You guys have to do these two things, and I will upload it to this two in classroom. Okay, I'll show you that. Okay, so one is this one using relay agent. Okay, with DHCP server is here, and this what 2.0 here it is 1.0, and don't this put this printer. Okay, you may just neglect it. Even if you put it, it will also get assigned with IP address. Okay, and you just assign an helper address over on this interface where this PC left side network would also able to get assigned with the IP address from the DHCP server, which is in this one. Okay, and this is the command I written here: helper address on particular interface, right? And the IP address of the server. Okay, and do the same thing for this network, which I did here. The same network which I kept here. Do the same thing for this network also. Okay. So the next one, we were doing it, what is called NAT, network address translation. Okay. What I will do, the same thing, for the same network, I'm doing this network translation. For your work, I given this to do the network translation. Okay. This is a network. I cannot create an internet over here, right? That's why I just assuming this part identified as an internet. Okay, and this is your internal organization or this is your network. From here, I just able to access a server or an internet which is in public. And we well know that network address translation is something is translating from private IP to public IP, right? For that implementation, what I will do, I'll just I'll just delete this portion. Okay, and I'll just connect these two. Okay, and I'll take one server. Okay, okay. Check, I think no more have IP address. Okay, still have IP address. Okay, not a problem. Okay. Okay, and then I will connect this server to here. So what I will do, I will just service and enable this HTTP, and both are enabled. And I will configure this with an IP address which is 192.168. Something 2.9 and 8.2.1 default gateway. Okay, so what I'm trying to do here, I'm just assuming this would be your internet. Okay, this is your ISP. Okay, your ISP network where your servers are publicly hosted in this ISP. But this is my organization. But when I do the NAT, so I should go outside. I should go with uh, public private should be converted to public, and public should be converted to private, because inside my network I use private address, and I go with public address towards a public network. Okay, so if I draw this would be your, and so this would be your network, and this is your internet. This is completely your internet. Okay, so but I can't talk with private IP address, right? I should change from private to public, and when I get back the reply, I should change from public to private. Hello, is it audible or any disturbance?
Yes.
It's audible. Rakshit cares. Okay. Okay. So we all know that that is something inside the organization. We use a private IP, which is this one, and I used to use a public IP address for this is something 60 dot network 24 something. Okay, and this is the again a private IP which is assigned between these two. Okay. For this implementation NAT, or what we kind of configuration we would be having between our organization and the ISP is something from here to here. It will be default routing. From here to here, it is something static routing. Okay, well, just disable this uh, RIP router RIP whatever I configured. I'll just remove it for the previous one what I did. RIP, I'll just remove that. And what I will configure now, so I'll just configure IP out, okay, which is 0.0.0, and this next top address is this address, which is 10.0.0.2. I should make sure this interface should assigned with the 10 dot address. And from here to here, I must have a static route. This thing you should always keep in mind. Okay, I'll just remove router RIP and just configure IP route is to the globe, which is public IP address which I have chosen. Okay, 60.0.0.0, and the subnet mask is 255.0. I will go with default subnet mask, and the next hop address is 10. Is address of this. Okay. So if I check the communication reachability between this and this, I cannot get it, right? If I do this, if I check here, it is failed. If I check the same thing in simulation mode, the reason is I sent an ICMP packet and it knows how to send to here also. It will receive and it will reach. Just checking it. Okay. If I clear it and if I do the same thing again, one and one, check this and send. It will receive, but it will send back and it will also get back, but it doesn't know where it should route because it's still in private address, but private address are not recognized in the internet, right? And it will drop the packet. I think you could see here it is failing. That packet will not forward it. It go back, get back. That's it. Okay, because from ISP to you, it is routed with a static routing which is given with this public address. Okay, the ISP will provide a public address, and from here to here it is always static. Okay, from here to here it is default. The default routing is 00.00. So whatever the traffic which we are generating inside my network, everything is forwarded to the ISP. So ISP will know where that packet should send. But when it get back in the replay, we should get the replay for the my public address. So then I need to have something a translation here. So along going with the private address, if I went after this router, if I went to a public address, I could get the replay back, right? Isn't it? So that is what NAT. Okay, so I'm just doing it NAT. Where I should implement? I should implement this NAT on my router, on my organization router, not on service provider network. It should be implemented on my router. I just wanted to say that this IP should convert it to a public IP. Okay, I'll just do that right now here. I'll come back to, to this router and I'm in global configuration mode and I'll just say IP NAT. Okay, and if I do the question mark, you will come to know what should be done. Okay, and I say inside. Okay, and type of with this one source. Okay, I'm doing IP NAT translation. Okay, source IP NAT inside means if I take here, if any packet comes to the outside through the network to do the translation, and source is which one? Where I'm doing this NAT, the source is that LAN itself is source and destination is the remote network. Okay, source, and I'll just say static. So there are three types of NAT implementation, right? Static, dynamic, and port address translation. Okay, static. Then I'll just give the local IP address. So what is the local IP address? This is my private IP address. 1.1.1. Okay, not 1.1.1. What is the address of this? Is 1.5. Okay, I'll just do 1.1.5 and I should do the global IP address which they assigned for me, the IP address here. And 60.0.0.0/24. Sorry, .8 I used, right? This IP address I must use. Okay. and I just say enter. Okay. If I do the same thing which I did the last time, okay, go to simulation mode and I just check the reachability between this and this. Capture forward, send over there, and then send to here, and it will comes to switch and it will goes to that server, come back and again that will receive. Again, it will not forwarding. Okay, what is the reason it is not forwarding? Probably this implementation is not happened because if I check here, uh, simulation mode, and if I do this here and here, capture and forward and here, when it comes here, I think if I inspect this packet, still I am going with the private IP, right? Private IP is this, and I public IP is 2.9. Okay, I'm still going with private IP. I have to change this to some public IP, right? So the NAT, whatever I've written, it's not implemented completely, right? I just globally written this rule on the router. For this IP, I should change to this IP. And I have to implement this NAT on interfaces, okay, where this translation should take place on the interfaces when any packet which arrives at that interface. Okay, just get into this interface, and I'll just say IP NAT, okay, IP NAT inside. Okay, that means I'm implementing this NAT on the interface. Okay, this NAT rules which I have written. Okay, here, if any packet comes to this router, okay, with the source IP which is 192.168.1.5, I should change that to which address 60.0.0.1, and it is static. Every time this source is and this device is sending a packets to an external network, outside the network it goes with 60.0.0.1. It will change that address to 60.0.0.1. Okay, where should this happen? On this interface, and it is inside. That's why I'm writing. I'm on this interface. I'm implementing this NAT rule saying IP NAT inside. So take this NAT translation, address translation inside this interface. Okay, okay. It will went and it will when once it's come back, I should again define a rule that IP NAT outside. Outside means again I should translate because this router only knows this device with this private address. I should again translate from this 60 to this one. Again, then this router knows how to route that packet to the proper device, right? So again, on the same device itself, I'll just come back to that interface and I will get into that proper interface, FA0/0. Okay, and here I will define IP NAT and I just say outside. This too is very important. If you missed with this, I think you will not get this properly. Okay, once you did that, you just check now, sent, sent. The moment a packet comes here, I think you could see the change over here. The change means it should go now. Okay, if I click on the next one, sorry, click next. I think this would be changed with, see, the source IP is now changed to, before it is forwarding to outside of this interface, it should change this IP address. What is the IP address now? Source address is 60.0.0.1. Okay, and that will forward it to the, then it will goes to the destination and you will get back and it will come back, and this router now for the routing where it should send 60.network to me, right? It will send that packets to me and it will come back and it will reach the destination, and where you see the successful. Okay, for more information, like here itself you could see this command do show IP NAT translation. Okay. So if you check this command, you can see here IPNAT translation. There is something inside global, inside local, outside global, outside local. So inside global is something means the public IP address of my organization, my network, and local is something the private IP, public IP, private IP of my local network, and outside is something the remote network to which network that you are sending a packet. That is outside remote network. Their private IP and their public IP. Okay, that is what this NAT table is about. I implemented only for this, right? And if I check on this, even I couldn't get that. Okay, because I statically configured this IP address should go with this. But rest of the routers, the rest of these PCs are not configured. So this will not.
Excuse me, sir.
Yeah.
Sorry to interrupt, sir, but
Yes. Yeah. Yeah.
actually, the automotive students might have class, sir. So that's why I'm interrupting now.
Now they have class.
Yes, sir.
Okay, the last thing I will complete it, the static routing. Okay, so for every devices in your network, if they do this translation, they were able to get the response from the network. If you do one and if you missed with rest, they will not able to communicate. So this is where a kind of implementation we still use when you are hosting a only one device over an internet. Okay, this is what static route. But again, using the static routing is not useful because how many private IP address you have, that many number of public IP you should purchase from the ISP. So that is really not helpful making use of efficiently of IP address, right? So we use something called dynamic NAT and another one is PAT. So I will continue this on Wednesday evening 4:30. If biomedical class is there, then we start with 5:30 to 6. I have these two to complete, dynamic and what is PAT. I'll do that in the next class, Wednesday, 5:30, 5 to 5:30 to 6. If the biomedical class is there, someone has to intimate. You just tell Ita to intimate me. If biomedical class is not there, I will take it 4:30 to 5. That's it. Okay, they can leave now. Whoever having this automotive class. I'll take the attendance for 45 students who are present. The rest, the 15, around 20 students were absent. I'll keep them absent. I have a list of them. Okay, fine. Thank you.